We're going to look at another question, which is very similar to the ones we looked at in just the previous couple of videos. Okay, we need to show that this fraction is irreducible for all integers n. So I'm just going to start by explaining what this word here actually means. And what you'll find is it has a similar definition to something you're quite familiar with. Okay, let's consider a numerical fraction, for example, 6/8. Well, this fraction, we can simplify it because the numerator and denominator share a common factor of 2. Okay, and then we get 3/4. Okay, whereas if I take a different fraction, for example, 5/6, okay, we can't simplify that any further. If I asked you why, a lot of people would say 5 and 6 have no common factor. That's not correct. If you take any two integers, they'll always have a common factor of 1. So the reason we can't simplify this one is because the highest common factor of our numerator and denominator is equal to 1. Now the top fraction, 6/8, is what we'd call a reducible fraction. Okay, because it can be simplified, because it has a highest common factor above 1. Whereas the bottom fraction is the irreducible one, okay, because the highest common factor is equal to 1. So essentially, we're talking about whether a fraction can be simplified or not. Okay, so in this question, where we need to show that this fraction is irreducible, essentially what I need to show is that the highest common factor of 5n plus 7 and 3n plus 4 is equal to 1. If I can show that, they're co-prime, therefore it's irreducible. Okay, so let's go through the process. First off, I want to find an integer combination of 5n plus 7 and 3n plus 4 that is equal to 1. Okay, and for algebraic expressions, we want to eliminate n. Okay, so we need to think, what can we multiply 5n by and 3n by to get the same number of n? So you're thinking lowest common multiple, so you can list out your multiples if you want. However, it's clearly going to be 15. Okay, so we need to multiply 5n by 3 and then 3n by 5. The next thing we have to figure out is signs, because one's going to be positive, one's going to be negative. So we want to ensure that we get positive 1. So let's just think about what else we get when we expand the bracket. We got 3 multiplied by 7, so that's 21. 5 times 4, which is 20. So I'd want to do 21 subtract 20, so therefore it's the 5 that's going to be the negative one to make that happen. Now we're going to go through the same proof that you should have seen in the previous two videos. So let h equal to the highest common factor of 5n plus 7 and 3n plus 4. Okay, therefore h is a factor of each of those expressions individually. And therefore h is a factor of any integer combination of those two expressions. Okay, and I'm going to once again just specify that a and b must be integers. Now we're going to refer to the specific case that we worked hard to find up here. So in the case when, and it's going to be a is equal to positive 3 and b is equal to negative 5, we get that h must be a factor of 1. Therefore, h is equal to 1, since 1 is the only factor of itself. So the expressions 5n plus 7 and 3n plus 4 are co-prime. So the fraction we started with, which was 5n plus 7 over 3n plus 4, is irreducible. Make sure you get that word in your conclusion.